Welcome again. Here are the objectives for this video. First, we would like to give a real or some real world uses of integers. Then we would like to graph numbers on a number line. And the final objective is to convert rational numbers into decimals. And so our first problem says to express as a positive or negative integer. Well, we better first define what an integer is. And let's start with some counting numbers first. 1, 2, and 3, 4. And we could keep counting up indefinitely. And these counting numbers have a name. They're called natural numbers. So the numbers that we use to count are called natural numbers. Now if we add just one number to this, just add the number 0 and then all of the counting numbers are called whole numbers. So whole numbers are 0 plus all of the natural numbers, 0, 1, 2, 3, 4, etc. On and on. Now if we take our natural numbers and take the opposite of them, for example, -1, -2, -3, -4, and so on, all of these numbers now put together, those negative numbers, also the 0, the positive numbers, these are called integers. So the integers are negative and positive numbers and 0. Those are the integers. Now to express as a positive or negative integer, we look at the word below. Below connotates a negative. So negative 25 is the integer for 25 feet below the surface. A surplus connotates positive, so positive $100. Or we don't need the plus sign, we can just write the 100 without the plus sign. Next, we would like to graph these rational numbers on a number line. But what's the word rational mean? Well, we know what integers means now, so what does the word rational numbers mean? Well, a rational number is the following. A rational number is any number that can be written in this following form as a over b, which is a ratio or a fraction. Written as a over b, where both a and b are both integers, and we know what integers are. But there's one condition to this. B cannot be equal to 0. But b is not equal to 0. So what are some examples of rational numbers? Well, 1 over 2, there's one integer over another integer. 1/2 is a rational number. How about 3? Well, 3 actually is a rational number because we can write that as 3 over 1. One integer over another integer. And now how about 0? Well, we can write 0 as 0 over 1, or we could write it as 0 over anything. Actually, we could write it as 0 over 3. All of these are equivalent to 0, so 0 is a rational number. How about 3 over 0? No, there we violate the fact that we have the bottom number equal to 0, and that is just not defined. So 3 over 0 is nothing. It's not a rational number, it's not an irrational number, it's just not defined. Now, to graph these rational numbers on a number line, we need a number line. So there's a line, and let's make some marks on this line. And oops, I was trying to write with the line tool and got rid of too much there. So back to making the marks on the line. There's a mark, another mark, another mark, another mark. And we would like this line to extend out forever, so we want an arrow on both ends. And some more marks on our number line. And now let's put some labels on there. Oop, that's the wrong. There, 0. There's where 1 is, 2, 3, 4, 5, and so on. And in the negative direction, -1, -2, -3, -4, and so on. We've created a number line. And now we would like to graph first the number 3. Well, the number 3 was one of our marks on the number line. There it is. So I just graphed the rational number 3. Okay, now how about -7/3? Well, -7/3, that's as a mixed number, that's 3 goes into 7 2 times with a remainder of 1. So that's the same as -2 1/3. So let's go out beyond -2, go 1/3 of the distance between there and -3, and that's where -7/3 is located. Finally, we have 0.4, which properly is said to be 4/10. Let's write it as a fraction, 4/10, and reduce that fraction. That reduces down to 2/5, and let's locate 2/5 on the number line. Well, it's between 0 and 1. Let's divide that up into 5 parts. It's 2 of those 5 parts over. Right about there is where 0.4 or 4/10 is located. Next, we are to write the rational number as a decimal. To do this, we simply divide the bottom number into the top number. So we're going to divide 4 into 1. And does 4 go into 1? It doesn't. It goes in 0 times. And so does 4 go into 10, however? Let's put our decimal point where it belongs there. 4 goes into 10 twice. We get 8. Subtract, we get 2. We need a 0, bring it down. 4 goes into 20 5 times. And 4 times 5 is 20, no remainder. So we've converted this into a decimal form, 0.25. Now we can do this just on the calculator. We don't need to actually do it longhand like we've been doing it. So let's just find out what 5/8 is as a decimal. We just enter 5 divided by 8 and hit enter, and decimal point 625. And I didn't put the negative sign in, but this is now a negative. And I don't think I'm going to have room here. Let's go down here. It's negative 0.625. That's what 5/8 is, negative 5/8 is as a decimal. And now let's do the next one, which, let me see if I can, 2/11. So let's enter 2 divided by 11, hit enter, and this is decimal point 181818. Notice that the 18 keeps repeating. And so how we can show this is right, 0.18, and if we just put a bar above the 18, that shows that it keeps repeating. Incidentally, all rational numbers can be written as either a repeating decimal like we got with 2/11, where it was 0.18 and 18 kept repeating, or as a terminating decimal, which we got with the other two fractions. 1/4 was 0.25 and it stopped, and negative 5/8 was negative 0.625 and it stopped or terminated. Okay, let's see if we've completed our objectives. We did give a couple of real-world uses of integers. We graphed some numbers on a number line, and we converted rational numbers into decimals. So yes, and of these I would say that the most important was probably what we did last, converting rational numbers into decimals. That's it for this time. See ya.